Hello and welcome to this tutorial video on chemical bonding. I'm Leisem. Okay, so what makes a man, a grown man and a grown woman to leave their families and come to start living together? Definitely it's love. There is a bonding. There is a strong force of love putting these two people together. So if we were to remove that love, then you have what we call separation. Now, similarly in chemistry, what makes hydrogen to combine with oxygen to form water? Okay, so that must be there is some forces that is attracting hydrogen and oxygen to be together. So such forces is what we call bonding. So bonding is simply a force of attraction. So a force of attraction existing between two or more atoms. Okay, so when you say the force of attraction existing between two or more atoms, these atoms, they don't need to be different atoms. They can be the same atoms or two different atoms or two or more different atoms. It doesn't matter as long as it's just not a single atom. If it's a single atom, then it's not a bond. So for instance, you can have same atoms. For instance, two hydrogen atoms can come together and then make a bond, or hydrogen atom and oxygen atom come together, or we can have, for instance, we can have, let's say for instance, hydrogen atom, carbon atom and oxygen atom, such as in hydrogen carbonate, forming a bond. Okay, so let's now go in details about these bondings. How is a bond formed? Now, the area we looked at the valence. In the earlier videos, we looked at valence, we looked at ions, we looked at electronic configuration. So we have to know how are the valences formed. So a valence, a bond sort, is only formed when an element either loses or gains electrons. So a valence is only formed when you either lose or gain electron. You form a valence, a bond, sorry, or even when you share electrons. So a bond is formed when an element loses or gains electrons or shares those electrons. So our task is to know which elements form bonds by losing or gaining electrons, or which one forms bonds by gaining electrons. So from our previous topic on electronic configuration, we said all those atoms whose outermost shells contains either 1, 2 or 3 electrons, they will lose their electrons. So elements such as, for instance, we'll start with the hydrogen, then you go to let's say lithium, then we'll go to neon, then we'll go to sodium, then we'll go to maybe, let's say, aluminium, or we can even look at calcium. So we have the first shell is MLN. So here on L for sodium we have only 1 electron, lithium 2, 1. Then for neon is 2, okay, so neon is 2,8. Then for sodium is 2,8, 1. Then for aluminium 2,8, 3. Then for calcium 2,8, 8, 2, which is shell 4. So what are we seeing? What we are seeing is that all those elements in which, so for hydrogen, the last shell is shell M, and it has how many electrons? 1. So this one can lose. For lithium, the last electron is 1 in shell M. So it cannot gain 7, so it can lose. But for neon, the last shell is fully filled, so this cannot lose nor gain. It is stable, does not form bond with anybody. But for sodium, the last shell is 1, it can lose. We come to, for aluminium, the last shell is N and it has 3, so it cannot gain the 6 to make the 5 to make 8. It can easily lose those, so that it just, so when it loses, what happens? Imagine aluminium loses that, it now it just remains with 2 shells, and the last shell will be fully filled, then it's stable. Okay, so let's look at calcium. So calcium is number 20, 2,8,8,2. It has 2 electrons in the last cell, so this can lose. So by now we have known that those elements with either 2 or more, with 1, 2, or 3 electrons in their outermost shells, they will lose. Whereas elements such as oxygen, so oxygen is 2,6, nitrogen 2,5, there you have, let's say, fluorine, which is 2,7. Imagine these, they have 5, 6, 7 electrons. Can you easily lose all the 6 electrons when you just needed to gain 2? No. So elements which have 5, 6 electrons in their outermost shells, they will easily gain electrons. So we know who gains and who loses. Now let's look at who shares. The rule is simple here. The rule is that you just check on the outermost electrons. How many electrons do you have in the outermost shell? So you can only share when, one, you have what, half of required electrons in the outermost shell. So how many electrons do you have in the outermost shell? If you have half of the required electron in the outermost shell, then you share. What am I trying to say? Let's say in shell L, the required electrons is 2. So let's say if in shell L, you only have shell L and you have 1, so 1 is half of 2, isn't it? So meaning you can just share there with another element, because you have half of the total number of electrons required in that particular shell, which is the outermost shell. So in this case, hydrogen, its electronic configuration is 1. And how many shells does it have? It just have 1 shell L. And how many electrons should be in shell L? 2. But it just has 1, and 1 is half of 2. So hydrogen can share electrons if it wants. So you know that hydrogen it can share, it can gain, it can lose, depending on which condition prevails. Another example is, let's talk of, for instance, you have the shells M, N, O, and so on and so forth. So these, they are filled to the maximum by 8 electrons. So what is half of 8 electrons? This is equal to 4 electrons. So those elements which have shells M, N, O, and so on, if they have 4 electrons in their outermost shell, then they cannot lose all the 4. No, manage to gain the 4, but instead they will share with another element. So for instance, let's talk of elements such as carbon. Carbon is number 6, so its electronic configuration is 2,6. So this is 2,4. So this is shell M, yes, shell L, shell M. Now you realize that in shell M, for shell M to be fully filled, we said it must have 8 electrons, but it just have 4, which is half of 8. So carbon can share. So that's the point. If you have half required number of electrons in the outermost shell, you share. The other way in which you can share is sharing of electrons only exist among nonmetals. So if nonmetals alone are involved in forming a bond, then they will share their electrons. So nonmetals, usually those are elements in the periodic table found in group 5, 6, 7. Yeah, 5, 6, 7, and 8, those are nonmetals. So let's say, for instance, if you have a nonmetal such as oxygen and chlorine. So oxygen is in group 6 and chlorine is in group 7. So if they wanted to form a bond, none of them can lose nor gain. But what they would rather do is share their electrons. You guys, we know that when you share things, they belong to all of you. So yeah, all of you will be using them. So even hydrogen sometimes, so hydrogen is a non-metal because it's a gas. So hydrogen usually likes, so if hydrogen is forming a bond with a non-metal, it sometimes it likes losing its electrons, or sometimes it shares. For instance, when hydrogen is forming a bond with oxygen, it shares the electrons. But when hydrogen is forming a bond with a metal, for instance, those elements in group 1, 2, or 3 of the periodic table, it usually loses electrons. Okay, so when you are forming we know how a bond is formed: by losing, gaining, or sharing. Now let's look at the types of bonds that you can form. There are 3 types of bonds that are formed. So we have what we call ionic bonds, or we call it electrovalent bonds. So this is formed when you either lose or gain electrons. So this is formed when elements lose or gain electrons. So that's what the first type of bonding. The second type of bonding is called covalent. The word co, together. So this is formed when you share electrons. The last type of bonding is called dative type of bonding. So dative type of bonding is formed when only one member donates the shared electron. Sometimes 2 elements will come together to share their electrons, but among the 2, the shared electrons, they just come from one particular atom. So the bond formed there, we call it a dative kind of bonding. So now let's go in detail in each of these types of bonding. We start with ionic bonding. The word ionic meaning, you guys, you know, an ion is formed when you either lose or gain electrons. So in an ionic type of bonding, usually this happens between an element that can lose and an element that can gain. If you just have elements that can lose, then you can't form an ionic bonding because no one will share. I mean, how do you have to benefit from us? You lose, then the other one gains. You give when there's someone to receive. So in an ionic bonding, there will be an element to give electrons, and then there will be another element to receive electrons. So let's take, for instance, you guys give me an example of an element that can lose electrons. Okay, we have let's say sodium can lose its electron, and another element that can gain electron is chlorine. So let's say sodium wants to marry chlorine. Sodium will lose electrons, then chlorine will gain electrons. So what is going to happen is that so we have this sodium, or sodium with its electronic configuration of 2,8,1, with chlorine of this electronic configuration 2,8,7. So what will happen is that sodium will lose this electron to chlorine, you see, so that after sodium has lost and it becomes an ion, it becomes 2,8. Then this one, after it becomes an ion, it becomes 2,8,8. So we know what will happen when you gain one electron from the previous video, if you watched it. So chlorine now will become chloride ion. This -1 means it has gained one electron. Then this one will become a sodium ion. So meaning sodium ion is positively charged, meaning it has gained one electron. So this is very important, you guys, to take note of it. Okay, so now how will be the bond? So the bond usually this to exist because sodium has lost an electron, whereas chlorine has gained. So the bond will be created by that losing and gaining of electron. Okay, so let's say for instance, okay, so we have this atom for sodium. Now I only represent the last, because when you are forming a bond, the only electrons which are important are those electrons in the last shell. Those electrons which take place in the bonding are the most important one. So you have sodium, okay. Sodium, when it has formed a bond with chlorine, this is how it will be. So you have a nucleus here, and we write the symbol for sodium. Then surrounding the nucleus, we have the shell. We have the first shell. Then since after being an ion it will only have two shells, then you have the next shell. Okay, so we have this as our sodium. Okay, my marker was a bit faint. Okay, so we have sodium. Now I need to put it in this, so you know it will be positively charged. So this is what we're going to happen. Initially sodium had how many electrons? Initially sodium had 11 electrons, but after losing, so it will have the first two in shell M placed like this, then it will remain with 10, so it will put the other 8 in this way. Okay, so this would be the way the atom for sodium will look like. Okay, let's go for chlorine. How will the chloride atom now after gaining the electron look like? Okay, so this one will be negatively charged. So for chloride atom, we're going to have inside, we're going to have the nucleus. Okay, so we have the nucleus will be Cl. Hope you guys are able to see. I'm writing Cl inside, and then we have the first shell. Okay, we have the first shell, which is shell L here, followed by a second shell, okay, which is shell M. Then we have the third shell, which is shell N. So now we have to put it. So the electrons for sodium, I represent them by a cross. What of the electrons for chlorine? So the electrons for chlorine, I'll represent them as dots. Hope you guys will be able to see this. No, the marker is not visible. Okay, let me use a blue ink. Hope the blue ink will work this time. Okay. It's looking black. Okay, black. Okay, so even here black. Okay, then here it's like black will work. These other colors are not working. So we have, okay, so remember only electrons in the outermost shell are very important, so these will be inside. Now we have 1, those are for chlorine, 2, 3, 4. Okay, so having this 4, then the 8th electron in the outermost shell, that is shell N, will come from sodium. So sodium electron, I'll represent it by a cross. So that is how you draw a dot cross diagram. So you have an electron which was lost by sodium's last shell, this shell here, this electron. So this electron is the electron which was lost by sodium from here, and it came here to make the outer shell to have 8 electrons, because it was converted into 80 electrons. So that's how an electrocovalent bonding happens. So the bond is between this now and this ion. That's why it's called an ionic type of bonding. So those elements in group 1, 2, 3 of the periodic table will form a bond with element in group 6, 7 of the periodic table. So the type of bonding is called electrovalent type of bonding or ionic type of bonding. So the other type of bonding that you guys will look at is the covalent one. So in a covalent, usually this is where you share electrons. Like I said, this exists between nanometals. So we'll start with hydrogen. So hydrogen gas. You guys will know hydrogen gas, that it's written like something like this. So I mean, imagine this is a hydrogen nucleus, and then this hydrogen nucleus is surrounded by another hydrogen. It's surrounded by a hydrogen shell. Okay, so this is let me present hydrogen nucleus by the red. Yeah. So we have a shell like this. So this shell, it contains one electron. Okay, let me present it in black. One electron. Then we also have another so this is our hydrogen atom. One hydrogen atom, and we have also another hydrogen atom here. So it will have a nucleus. Then this nucleus will be surrounded by a shell. This shell contains one. So yeah, let me represent this electron for the other hydrogen in this car. So you see, you have these two hydrogen atoms. These two hydrogen atoms want to form a bond. So they want to form a bond. What type of bond? Neither of them can like to lose. So if you can't lose, then the other one cannot gain. So what are they going to do? What they're going to do, these guys, they'll say, okay, all of us just have shell L. What if we share our electrons? So if we share our electron, they will become like this. Okay, these guys will come together like the way these guys will do. They will come together and have a new shell here. So they will come together. Okay, they will come together and do something like this. So this hydrogen is this one, and then this hydrogen is this one. So this is the hydrogen here, this nucleus, and this is another hydrogen. So what they will rather do is that this hydrogen will come with its own electron. Okay, it will put it here. So this electron is coming from this hydrogen. Then this hydrogen also bring its own electron. So it will bring its own electron and put it here. So this electron is from this hydrogen, then this electron is from this hydrogen. What do we get at the end of the day? So what we get at the end of the day is two electrons. And how many shells is each hydrogen atom having? Just having one shell. So what do you get at the end of the day? We find that how many shells will this hydrogen have? Shell L. Even this one will have shell L. So when they share them, they come together like this. Each one just have shell L. And each shell L, because these two electrons belongs to both of them, so they are stable. Therefore, that's how a covalent type of bonding happens. So this can also happen, let's say for instance, between let's say we have head of water, isn't it, you guys? Water molecule like this. So what happens is that we have an oxygen atom like this. Okay, so here we have oxygen. So this is the nucleus. So oxygen atom, then this oxygen atom will be married. Yeah, allow me to use that term. So be married to two hydrogen atoms. Two hydrogen atom. Remember, a hydrogen atom just have one shell. Then oxygen atom have many shells, but I'm only showing the outer shells. So what will happen is that hydrogen atom will donate first one electron, and then oxygen will also donate 1 electron. So the electron for oxygen will be in form of a dots. So remember, oxygen needed how many electrons to be full? Needed 2. So they are sharing them. Okay. What is important is this kind of bonding. I know you guys, this might not be clear, but if you use the reference this as the one, then it will become clear. But what is important is that the shared electrons belong to both. So if you are to count for the oxygen here, we'll start with this one. 1, 2, 3, 4, 5, 6, 7, 8. So here we have one atom from this hydrogen plus one here donated by oxygen. So even here you have one atom from this hydrogen, and then the other one donated by this oxygen. Now the point to note is that the shared the shared electrons belongs to both atoms, because even this electron for oxygen is counted to be part of hydrogen. So both elements are stable. So such kind of bonding, we call them a covalent type of bonding. So what are the differences between electrovalent and covalent type of bonding? In electrovalent, like we saw in the previous discussion, we saw that in electrovalent we produced ions. Ions were produced in electrovalent, whereas in covalent there are no ions. So that's the first difference. In electrovalent type of bonding, atoms either lose or gain electrons, while in covalent they share electrons. So that's another second difference. The third difference is that usually most of the compounds that are formed by ionic type of bonding, they are solids at room temperature, whereas those in electrovalent, those in covalent, they are either liquid or gases at room temperature. So these are some of the differences. Even the properties, when you talk about the properties for a compound formed under ionic bonding, 1, it's a solid at room temperature. 2, it has ions, so it can conduct electricity. And number 3, since it has ions, the force of attraction in ions are very strong, so it has high melting point. Unlike in covalent type of bonding, where they are either liquid or gases at room temperature, and they are very volatile. A liquid is volatile, they can easily evaporate, and usually they have low melting point because of the force of attraction is weak when electrons are shared, unlike when electrons are lost. Okay, you guys, I think we have to end here. Although we haven't covered dative, I think I'll cover it in the next tutorial video. So if you like this video, please remember to like the channel, leave a comment on where you think we need to add or subtract, and most importantly, subscribe to the channel so that you receive updates on the new videos.